Hey everyone, welcome back to the College Algebra playlist. In this video, I want to continue our discussion of functions. Alright, namely, I want to take a look at the domains and ranges of specific functions. Alright, we already looked at domain and range a little bit in the playlist, but I want to dive into much more detail in this video and talk about what the domain and range really mean. Alright, so let's dive into it. Okay. Here we go. Domain and range. Let's write down the original definitions that we had for the domain and range. All right. First of all, a relation is a set of ordered pairs. All right. And a function is a special type of relation in which every possible input value corresponds to exactly one output value. All right. The input values make up the domain, and the output values make up the range. Okay, so here's the example that we had in a previous video. All right, this is a set of ordered pairs. All right, so it's a relation, and it's also a function because each input corresponds to just one output. All right, so the input values are the values in blue, right? Those are the values that make up the domain. Okay, so we have this set of numbers here. All right, and the range, right, that's made up of the output values. So it's got the red numbers. Okay, so these two sets define the domain and the range. All right. When determining the domains and ranges of functions, we need to consider what is physically possible and or meaningful in real-world examples. All right, and we also need to consider what is mathematically permitted. Okay, we can't have division by zero, and we can't have negative numbers under square roots. All right, so the domain is actually the answer to the question, what are we allowed to plug into the function? All right, and the range is the answer to the question, what are the results? Okay, let's try an example. Here we're asked to find the domain of the function f of x equals x squared minus 1. All right? We can see right away that we can just plug any number we want into this function. All right, there are no restrictions, right? There's no division by zero potentially happening, and there's no square roots. So the domain is all real numbers, all right? And remember that the domain is a set, all right? It's a set of numbers. All right, in this case, it's a set of an infinite number of numbers, okay? And there are four ways that we can express sets of numbers, all right? We talked about this in one of the inequality videos, all right? So the domain, we can state it verbally, right? We can say the domain is all real numbers, or we can draw a number line, right? And in this case, we shade everything on the number line, all right? And there's also set builder notation that looks like this, right? It says, this is the set of all values x such that x is in between negative infinity and positive infinity. All right. And finally, there's interval notation. All right. This is the notation we'll use most frequently in the playlist. All right. So the domain is everything from negative infinity up to positive infinity. Okay. Let's try a different example. All right. Here we're asked to find the domain of the function f of x equals x plus 1 over x minus 2. All right? And we can see right away, just by looking at this function, that we have a restricted value, right? We can't have x equals 2, because if we plug a 2 in for x here, we get division by 0. All right? So the domain of this function is all real numbers except 2. All right, we can plug anything we want into this function except for 2. Okay, here's what that looks like on the number line, right? We have everything shaded from negative infinity up to 2, and then 2 up to positive infinity. 2 not included, so we have a circle here. All right, here's what it looks like in set builder notation, and here's what it looks like in interval notation, right? It's the union of two intervals. Everything from negative infinity up to 2, or everything from 2 up to infinity. Okay. It's not always going to be that easy though. All right. In the previous example, we simply looked at the function and we could tell right away what the restriction was, right? What the value that caused a problem was, all right? In this example, though, it's not that easy, okay? We don't know what value will cause division by 0, all right? So what we do is we actually set 2x minus 1 equal to 0 and then solve for x, all right, to find that problematic x value, okay? So let's isolate x by adding 1 to both sides, all right? And that gives us 2x equals 1, okay? And then let's divide both sides by 2, and the 2's cancel on the left-hand side, and that gives us x equals 1/2, all right? This is the value that is not going to be included in the domain, right? This causes division by 0, okay? So our answer in interval notation looks like this, all right? Everything from negative infinity up to 1/2, or everything from 1/2 up to infinity, okay? Let's try another one. Here we have f of x equals the square root of 7 minus x, all right? Let's give this blue stuff under the radical a name, all right? Let's call it stuff, all right? The stuff must be greater than or equal to 0, all right? We can't have the square root of negative numbers in this function, all right? We're not looking at complex functions in this playlist, all right? That's a topic in complex analysis, all right? In this playlist, right, we're only worried about, we're only dealing with real valued functions, okay? So we want real numbers. So the stuff must be greater than or equal to 0, so we can write that down like this as an inequality, all right? And the stuff is just 7 minus x, all right? So that's how we set up an inequality that we're going to solve, right? We're going to solve this inequality, okay? So let's isolate x. Let's subtract 7 from both sides, all right? And that gives us negative x is greater than or equal to negative 7, all right? So then we divide both sides by negative 1, all right? And because we're dividing by a negative number, we need to flip this inequality sign, all right? We get x is less than or equal to 7, okay? So this tells us what the domain is, all right? It's everything from negative infinity up to 7, and 7 is included, so we use a bracket there, all right? So that's our final answer. Now let's consider the domain and range when we're given a graph, all right? This is just some function that we have pictured here, all right? We don't know what the function formula is, but we have a picture, and we can answer the question, what's the domain and range, just by looking at this picture, all right? The domain, right, that's all of the x values that make up this curve, right? Remember, this curve is actually defined by an infinite number of coordinate points, all right? And the domain, right, is just the x values of those coordinate points, all right? And the range, right, that's made up of the y values, okay? So just by looking at this graph, we can say right away what the domain and range are, all right? The domain is everything from negative 4 up to positive infinity, all right? Those are the x values that make up those are the x values that are involved in the coordinate points that make up this curve, okay? Notice that we read it from left to right like it's a sentence in English, okay? The domain is negative 4 up to positive infinity, all right? And the range, we read it from bottom to top, all right? The range is everything from negative infinity up to 4, all right? And negative 4 is included in the domain, so we use a bracket, and 4 is included in the range, so we use a bracket. All right, these are our answers. Let's try another one, all right? Here we're asked to find the domain and range of the function whose graph is shown below, all right? So we have a hole here at negative 3 comma 0, right? The function is not defined there, all right? And we have a point down here, all right? The function is defined here, all right, at 1 comma negative 4, okay? So what's the domain? Right? It's the x values in between negative 3 and 1, all right? Negative 3 is not included, so we use a parenthesis, and 1 is included, so we use a bracket, all right? That's the domain. And the range is everything from negative 4 up to 0. And you say, Luke, 0 isn't included here in this hole, so why are you using a bracket? because this graph actually does hit 0 right here at the origin. Right? It passes through the origin, so 0 is included in the range. All right, so that's our final answer. Here we're asked to find the domain and range again, and we have a different function, right? We have f of x equals 2 over x plus 1. All right, we can look at this right away, and we can see that x equals -1 is a problematic value, right? We can't plug that into this function because then we'd have division by 0. So the graph of this function actually has what's called a vertical asymptote at the line x equals -1. All right. We'll talk more about asymptotes in a future video. All right. For now, though, we just need to know that x equals -1 is excluded from the range. All right. So the domain is everything from -infinity up to -1, union everything from -1 up to infinity. All right. And the range, we have something similar going on. All right. We have everything from -infinity up to 0, union everything from 0 up to infinity. All right. So this graph never actually touches the x-axis, right? It never touches the line y equals 0. So 0 is excluded from the range. All right. So this is our final answer. All right. Let's try one more. Here we have the function f of x equals 2 times the square root of x plus 4. All right. We know that we need to set this stuff under the radical greater than or equal to 0. All right. We have to have non-negative numbers under the square root. All right. So let's isolate x here by subtracting 4 from both sides, and we get x is greater than or equal to -4. All right. And that's the domain. All right. The domain is everything from -4 up to positive infinity. All right. And the range is everything from 0 up to positive infinity. All right. So that's our answer there. Okay. That does it for this video. Thank you for watching, and like and subscribe.